Welcome to another GCBASIC demonstration. This is part 18 for the PICINFo chip family. Please like and subscribe. Watch the video all the way through. It counts against my metrics. I'd be very grateful. Thank you. So this is focusing on the toolchain. Did I say that at the beginning? Not really, but it's focusing on the toolchain to get everybody up to speed. So GCBASIC is an open source compiler for PICs, AVRs, AVR-DXs, etc. LGT, common theme is for all 8-bit. It now supports Q20 and many others, obviously, but this is focused on Q20. And GCBASIC is cross-platform with common code translation, and we'll look at some of that. So look, the first thing you need to know in 2024 is that it's like Jekyll and Hyde. You've been watching one editor in these videos, but there's two editors available. So I'm going to take you out to the GCBASIC website, and we're going to have a look at that website. And essentially, you could choose two different approaches, but GC Studio is the overarching tool. But in terms of IDEs, it's like Jekyll and Hyde. You can, if I zoom in for you, how do I zoom in here? There we go, zoom in. You can do it in like a Visual Studio type approach, which has got a huge amount of capabilities, or the legacy Synwrite, and that has nowhere near the same capabilities. It still works, it's still fully supported, but all the development is inside of this one, which is called GC Code, based upon the open source software. So we can keep adding features to GC Code. This is static and it hasn't been developed since 2022. So if you want to see what I'm demonstrating, you've got to use this one, which is the newer one of the two. That's an important piece to understand. It is Jekyll and Hyde. Some people want to be with the old one, and that's absolutely fine. Because we've got a whole load of programmers that are installed, and there's so many different programmers that have been installed, and we'll have a look at the vast number of programmers. And if you have a programmer that's not supported, just let us know, or we'll integrate it. It's not hard. We have the GCBASIC IDE called GC Studio, and that is a great piece of software, and it manages the total environment, allows you to do so many things at the higher level before you start editing. We've got program editors. We've got things like PPS tool. We have AVRInfo, PICINFO, version of CLC, terminals, all installed with the IDE. It's a full programming environment. You shouldn't have to go hunting around for everything. And there's no requirement to do anything external, which basically means if you want to install your own programmer, you should be able to create configuration and configure it, not create batch files and things like that. You should be able to configure it. That is our goal. Keep it simple. So within GC Studio, this management environment which delivers the software to you, you get these, 12 different capabilities. I'll take you to the website, be quicker, to be quite frank. Okay, so GC Studio supports very deep integration with the GCB compiler, GCBASIC compiler. It is amazingly deep. It does things that you can't do in the old IDE. For instance, it knows about the compiler more. There are more APIs published that we can actually make that work. You can have multiple routes, which means you have folder structures, multiple files, and you can create your own project environment. You can select multiple programmers. So if you have a particular chip attached to one type of programmer and you want to have a different programmer attached, you can do that. You can switch between programmers, auto-select with a cascade of operations. GC Studio does automatic updates. It maintains the system. As we change the system, it gets maintained. You can support PDFs, spreadsheets, images, etc. You don't need to go outside of the IDE anymore. And you get automatic error detection. It's integrated, so if you see there is an error, it would take you to the error condition. And if it's a system file, it will take you to the correct system file, so you can have a look. You've got built-in Git. I also use SVN. You can put it's built in. You can create your own extensions because, to be honest, GC code is a complete extension that we've written from the ground up for this environment. It didn't exist. So we've written all that, and that gives us the ability to have a huge amount of intelligence within the editor. You have syntax highlighting. Yes, it's based upon Microsoft Visual Studio, or VS Code, not Visual Studio, sorry. And it's open source with no telemetry. That's all been removed. And you've got unified help. So this is the environment to move forward. It's where we're going to keep developing. And in 2025, there's even more developments coming in inside of that environment. Let me just go back to my video, my PowerPoint, wherever it is on the screen. You can see all my screen now. The toolchain itself consists of many, many different tools from many different suppliers, and you can look at this to your heart's content, but there's lots that's maintained by us, and there's lots that's maintained by third parties. So when you have a problem, just post it up to the forum, and we'll see what we can do about getting it resolved. But this diagram shows that we've got components that work in Windows, components that work in Linux, BSD and Mac, etc. And that particular versions of compilers are integrated as well. I mean, we use external compilers and linkers. They're all listed, so these are all included. But let's look how the core compiler works, because that's where the value is. So the core compiler is made up of these very simple blocks. I wish it was that simple to maintain it, but this is how I sort of visualize it. You have your own source code, the high-level language called GCBASIC, set of libraries that you can call upon. And they are merged as you compile this and press whatever button you press, goes through the preprocessor and it sucks in the libraries it requires. And it's automatically detecting all those libraries for you. Goes into what I call, goes into a code translator, which normalizes the code and brings it to a standard that can be then used across all the desired chipsets. It's assembled specifically for a particular chip that you selected. It then produces output files if you require, like an ASM file. It produces reports at this point. And then there is a linker called GCASM that will produce absolute machine code for a hex file, which you can then program. That's how it works. It's as simple as that. Not too hard, but this is one unit. There isn't a preprocessor piece of executable or code. It's just all inside of one simple command line application. But not everybody, you might have a desire to use an alternative linker, and you can do that. So you can take your source code again, it goes to its preprocessor, pull in the libraries, code translation assembler, and it will still produce the assembly line language file. It could be for a specific PIC that needs it needs PIC-AS or particular linker. Or it might be for AVR-ASM and you need to use AVR-ASM2 because you're going to put it inside the debugger. And we'll look at that tomorrow in the next video. It can externalize to the external linker, and then that will automatically generate your hex file. And then guess what? GCBASIC picks up your hex file and it will then load it into the chip. Very simple. Now, if in your source file you change the target chip, all the processing is automatic, and we'll look at that shortly. There's variants for Linux, BSD, and Mac. They're from downloads upon SourceForge, and they have programmers, an editor, and scripts, and the rest of it just works because all the libraries work, all the compilers work, etc. So what we're going to do is have a quick look at other pieces of the puzzle like PICINFO, AVRInfo, PPS tool, and editor preferences, which is quite important, and some code portability. Now I'm using, quite clearly, I am going to be using GC code. And if you want to change the color of the screen, you can go Control K, Control T, and you can make it into black. Control K, Control T, I'll put it back to light. Okay, let's look at some of the options we've got. Function key F4. We have got a whole list in here, and it's growing this list. I'm going to type PIC, PICINFO, start it up. PICINFO is a tool that has the information that GCBASIC uses, so you might as well use the same information. Bring it into focus for you. This is my chosen chip. What is it? I had a 16Q20. Click, and it says it's got the configuration options here. And these are ones with stars, all the ones that GCBASIC has defaults to. If you don't like the defaults, like you want to use the reset here, you can change that, copy the config, and I will just create a simple file in here. I'll just call up one I'm always using. I will just simply delete all that code. Now I took that in PICINFO, I took a copy of the config, I can then paste it in, and I've got a copy of the configuration that I just selected in PICINFO. So you don't have to sort of move it across manually, you can just do a copy paste, job done. In here, it's all the chip data, all the things that are exposed, and this is in just to make, it's useful information to know what family it is, what the program size is, EEPROM, RAM, IOs, etc., etc. Inside of here, you've also got all the options you've got, but that's related to the configuration, but you should be able to select those from the drop-down menu. All the registers are documented, all the bits are documented for you. And then finally, the interrupts, which are really important. People ask, what's the interrupt name, etc. They're in here. So if you wanted to set up, let me think of a really good example. Port change. Oh, take a port change one. Port change. In your source program, you can on. And you can see intelligence sense work in here. On, interrupt, Control V, call, ISR. I'll put the ISR. I mean, I'll just make a sub called ISR, end sub. And it is a complete program, by the way. Function key F6, just test compile that. And guess what? That is truly compiled it in those few seconds. So look, it's compiled it with no errors. So PICINFO is extremely useful for working out what's going on for that specific chip. In terms of all the chips, these are all the PICs. Let's do something like that and delete it. Okay. If you wanted to look at the same for AVR, so I'm going to put an AVR in here. So hash chip mega. Think of one of the new ones, 4809. There we go, 4809. Option explicit. Now, if I want to do the same for AVR, I'll go AVRInfo. Similar tool opens up. Slightly different logo at the front, and you can do things in here which we didn't do in PICINFO. So I'll have a look at that, shall we? In here, you've got, I ought to select a chip, I suppose. What's my chip I've selected? MEG Mega 4809. There it is. It's just populated it on the front there. It tells me the DFP pack, memory sizes, number of RAM, and data sheet. I can go direct to the data sheet, the same as you can do. These menus here are the same on the PICINFO tool. Chip data, similar. AVR masks, you might want to know about AVR masks, all the registers, all the bits, and all the interrupts. But what you can do, as in PICINFO, you can take the DAT file, the configuration file, direct to the IDE. You can open up AVR-DX. You can go to the data sheet and the website of the documentation, etc. But there is no configuration for this particular chip, but it gives you the overview of what we can do, what we can see and do. Now, what is important is the preferences. And so I'm going to go at it. I can select it here inside of AVRInfo or PICINFO. If I select it, if I select it properly, it opens up preferences. Cancel that. If I'm inside the IDE, you can do function key F4, type in pref, PRE, and it will open up the same thing. And in here are all the programmers. In here are some compiler options, and in here are some tool variables. I'll explain. These are a full list of all the currently available programmers. If you want to add your own, there's an add button. I'm using PICKit Plus Command Auto as my default. If I wanted to use C Nano, I would literally drag it up to the top. But it would only select that one depending upon some parameters because of the cascade that's built in. It will only select that if it's an AVR and it's chip family 140. So how do you know it's chip family 140? Go and look in AVRInfo. So if I look in AVRInfo, what chip family is it? DFP 140. There we go. That tells us quite a lot. Chip data, let's have a look in chip data. What's it saying here, chip family? A lot of information in nowadays. But there is a lot family, 140. So we'll try and explain. Back into prefs. It will only use this chip programmer, these command lines, when these two conditions are met, because it says AVR has to be defined and chip family equals 140. So it's useful to know all these things. So even if I tried to program my Q20, it would ignore it because it's not an AVR. And the same for LGTs, and there's many rules that we've set up for you to use. What else is in it? Compiler, you can show your basic in your source program. Let's do that. That's what it's set to do currently. Let's just have a look at that. Function key F7. Here is all the comments in this source code. Look, there's loads of comments. If I change my preferences, take that off, press OK. Press function key F6 or compile the hex, doesn't matter which one. It's generated a whole load of hex now, and there's no comments in here. There might be mandated comments like this one here. It says you got an idea what's going on, but look, you don't really know what all this assembly is doing. So if we go back into press editor and just turn that back on again, show basic, recompile function key F6, we will see it recompile, and now it's added in proven, internal. It's got all this commentary in here, look. And so you can then work out exactly what it's doing. Very useful. Press editor. You can suppress these two at the top, verbose, suppress. You can actually see a lot more information about the compilation process. You can get support for single advanced variables. You can get what's called CDF file, and that's a constant definition file. If you want to know what all the constants are, open up that file. Let's do that. I'm looking at my source program, right-hand mouse button, revealing file explorer. If you now look in here, there's a thing called a CDF file. Double click it. And here are all the constants and exactly where they were created, by which file, etc. And all the custom logic that's been set up. So if you wanted to know what chip family it was, just type in Control F, family. I guess I should have just typed in chip family. That would have been faster. Does that tell me what it actually is. Oh, this is all the logic, not the finals. I want the finals. I'll just cursor down to finals. You can see there's a lot of constants set up. And in here somewhere, it will say chip family 140. Here you go, final constant. Because they do change. You can mute them at banner messages and you can treat errors as warnings. And here is my assembler. I can select GCASM, that's the internal one. I can use PICAS, obviously it has to be a PIC and it has to be supported by PICAS. MPASM, it has to be a PIC and it has to be supported by MPASM. AVR-ASM2 has to be AVR and it has to be a chip that's supported by AVR-ASM2. And how do I know where all these are going to get compiled against? Inside the tool variables. And in here, it will tell you exactly where it's picking up the compilation information from. The preferences replaces historically a lot of batch files that used to exist. I pressed OK. So let's look at something. Let's look at this. We're going to set a DIR, port C, not 0, isn't output. And then I'm going to set that. I'll do a do loop. Do loop, loop. And then I'm going to toggle that by using a not statement. And we saw this right from the beginning. And I'm going to compile my source code. Function key F6. Or select the top right and H. And it's create some file. I'll shut down the now. I'm just going to drag that file to the right hand side of my screen because then we can look at them simultaneously. Here is the assembler. What am I going to show you? Code portability. This is for Omega 4809. If you look at the right hand side, it says here is my port change, and it's been optimized into a single instruction by the compiler. Very clever. Hey, let's change it to Omega 328p, compile. The code looks shorter, and here it is the same command in longhand because it doesn't have the same capabilities. The Omega 328 is not the same as a 4809. It has different capabilities. Let's change that to, so you can see it's a lot more instructions. Let's change this to a PIC18FxxQ20 because that's what we've been dealing with. But compile that. Completely different set of code. Let's look at this instruction. Now it's using a completely different instruction set. It's really portable. So if you write code in GCBASIC, you're creating portable code, and this should work. There is no reason why it wouldn't work. Our intent is to make sure that works for you. So it sets up the chip very differently. If I change this to a, I'm trying to think what an LGT is, so I'm just going to, I can't remember what an LGT is, so I'm going to use the intelligence. There you go. Look. They're these different ones. This is a different manufacturer's chip, but this is code portability. I'll just press function key F6, and here is the code for that. And all the other instruction sets operate the same. So that means that GLCD will work on an LGT, on a PIC, on an AVR, the same. Code portability, and that is one of the huge benefits of using GCBASIC. That's what I wanted to show you. Go back to my presentation. So, next video is using those assemblers I showed you, alternatives, MPLabX. We'll have a look at doing some debugging as well, and then the final video is just getting out and summarizing what we've seen. Enjoy.